Okay, let's talk about one of the most critical and honestly under-discussed challenges of our time. We're going to call it the Great Water Mismatch. And it's all about this growing, really dangerous gap between the fresh water our planet has and what we as a civilization are demanding from it.
You know, when you see those pictures of Earth from space, that beautiful blue marble, it's just covered in water, right? So it seems kind of crazy to think that we could ever face a water shortage, and yet we are. So what gives? How can a planet that looks so rich in water be so incredibly thirsty? That's the paradox we're going to unravel.
So to really get this, we have to start with one basic, non-negotiable fact. The total amount of fresh water on Earth is fixed. It's all part of this giant closed-loop recycling system. You might remember it from science class as the hydrological cycle. But a better way to think about it is like the planet's own plumbing. It just moves the same water around and around. And here's the kicker. No new water is being created. Seriously, what we have right now is all we're ever going to get.
And that finite supply, well, that's one half of this massive global problem. This is the Great Water Mismatch. It's this growing and frankly pretty scary imbalance between the water nature provides and what our civilization demands.
Okay, so how do you even measure a problem this big? Well, experts don't just look at, how much it rains. They bring it down to a really human scale. It's all about the amount of usable, renewable, fresh water that's available for each person each year. This is how you take a huge global crisis and see what it actually means for you and me.
And here's how they break it down. If your region has over 1,700 cubic meters of water per person a year, you're pretty much in the clear. No stress. But once you dip below that number, you're officially in what's called water stress. Drop below 1,000, and now we're talking water scarcity. And if you're under 500, that's absolute scarcity. And that is a full-blown emergency. All right, so we've established the supply side is fixed. Got it. But what about the other side of the equation? What exactly is making our planet so incredibly thirsty?
Well, it really boils down to two fundamental drivers. First, population growth. It's simple math, right? More people means more water is needed for drinking, for cleaning, and especially for growing food. And second, economic development. As countries develop and our living standards rise, our collective water footprint just skyrockets through industry, energy production, you name it.
Now, when you think about water use, you probably picture turning on a tap, maybe a factory pipe. But what would you guess is the single biggest user of our freshwater resources? I mean, by a huge margin. The answer might surprise you. It's agriculture. A staggering 70%, 70, of all the fresh water we pull from the planet goes directly to irrigating crops. Now compare that to industry and energy, which use about 20%. And all of our domestic use, showering, cooking, cleaning, everything we do at home, that's just 10%. It's wild.
But here's where the story of our water demand gets really interesting. There are some surprising twists. It's not just about the water we see coming out of the tap or the sprinkler. There are these massive, hidden water consumers all around us. For instance, take energy production. The rise of hydraulic fracturing, or fracking, has created this massive new demand for water. Each and every well can slurp up millions of liters, putting incredible and often unseen strain on local supplies. It's the hidden water cost of our energy needs. And this brings us to this kind of mind-bending idea called virtual water. It's essentially the hidden water footprint of everything we buy and use. It's the water that was needed to grow the cotton in your shirt, to raise the cow for your burger, and to manufacture your phone. It's this vast amount of water you consume every single day without ever turning on a tap.
Let's make this real. The t-shirt you might be wearing right now, from the cotton field to the factory floor, producing it required about 2,500 liters of water for just one shirt. And you think that's a lot? A single kilogram of beef has a water footprint of around 15,000 liters. And the vast majority of that, it just goes into growing the food for the cattle. So what this means is that when countries trade goods, they're also trading massive amounts of this virtual water. Now, on one hand, this can be a great solution, right? A dry country can import water-intensive food instead of draining its own aquifers. But on the other hand, it can also just export the problem, shifting the water stress from one part of the world to another.
Okay, so we've got a fixed supply and a rapidly growing demand. Now, let's add the final and most powerful piece to this puzzle, a factor that isn't just increasing demand, but is actively shrinking the supply, and that's climate change. You see, climate change acts as a powerful threat multiplier. It attacks this water mismatch from both sides. It shrinks the supply by totally scrambling historic rainfall patterns, making dry places drier and causing more intense, prolonged droughts. And at the exact same time, a warmer world means more evaporation and a higher demand for water in agriculture. It's squeezing the whole system from both ends.
So what happens when all of these pressures combine? What are the real-world consequences when the demand for water finally outstrips the supply?
The impacts are profound, and they're all connected. Our food security is threatened. Economic development can literally grind to a halt when industries run dry. Human health and sanitation are put at direct risk. And perhaps most dangerously, it raises the very real possibility of conflict as communities and even entire nations begin to compete for this dwindling vital resource.
All of this leads us to one simple, yet incredibly difficult question. On a planet with a finite supply of fresh water and a seemingly infinite demand, what is water truly worth?